So let's see the laws of logarithms. There are different properties, just as we have seen recently. Log a to base a is 1 and log 1 to any base is 0. Similarly, there are many properties connecting logs. The most important being log ab is log a plus log b and log a by b is log a minus log b. So let's see the properties which we can prove using exponent formulae. So initially, the first law states that log xy is log x plus log y. This is what is the first property of logarithms. Log xy to the base a is log x to base a plus log y to base a. We can split the product in the log splits as the sum of the logs. So let's see how we can do that using a proof. Now, because x and y are given, let me take x and y in the exponential form. So let x equal to a power n and y equal to a power m, where a is greater than 0 with a greater than 0 and a not equal to 1. Then immediately I have x equal to a power n implies log x to base a will be n. By using the form of exponential connected to logarithms, the formula as taken in the previous session, and this would give me log y to base a equal to m, is what I get with the two different properties from this. Now, because I want to find log xy, let me consider initially with xy. So x into y as taken from here would indirectly be a power n times a power m, because x is a power n and y is a power m. Substituted and the product gives me a power n times a power m. This, using the first law of index, gives me a power n plus m because the bases are same. Therefore, x into y is a power n plus m implies I apply log on both sides so that I get log applied on the left hand side to the base a gives me this, and log a power n plus m to the base a, where log is applied to the base a on both sides. Now, after I apply the log on both sides, then I can simplify this to be simplified further so that I get log xy to the base a is nothing but this comes out, because we know that log a power m is m log a, the formula which says that log a power m is m log a. The power comes as the base outside the log. So using that, I get n plus n times log a to the base a. This is strictly by using this formula. Now, when I continue with this, the left hand side becomes implies log xy n plus 1 times of 1, because log a to base a is already proved to be 1 just now, since is 1, as we have already proved that. So in this case, finally it reduces to log xy to the base a is n plus m, but when n and m are individually substituted out here, I find that n is log x to base a. So in place of n, I have log x to base a. In place of m, I have log y to base a when substituted individually for n and m. Therefore, finally, I conclude that my left hand side, which is log xy to the base a, is log x to the base a plus log y to the base a, thus deriving finally a formula which states that log ab is log a plus log b, provided the base is same. So the product comes out as the sum, is how we understand this property. Now, coming to the second law, the first law of logarithm is what we have seen in the previous case, Similarly, we will see the second law of logarithm, which states that log x by y to the base a will be log x to the base a minus log y to the base a. So when I take the division comes out as subtraction, the multiplication comes out as addition, is how we understand the properties. So similarly, this can also be proved, and it's quite easy because in case of this, I use the condition a power m into a power n is a power n plus m, but in this case, when I take x by y, I get this to be a power n by a power m, which comes as a power n minus m, the rest of them being similar. So this is the hint I can give in understanding this proof, as similar as the proof 1. So wherever I had x into y, I got a power n plus m, but wherever I want x by y, I get a power n minus m, the next law of index, and through this I derive where everywhere I get minus. It is as similar as the first proof, the only difference being that here I considered the multiplication, but here I'll consider the division, the rest of the proof followed by the division on the every step. Now, with this second law of logarithm, which states that log x by y to the base a is log x to the base a minus log y to the base a. Now, here I halt because I have been using log a power m is m log a, but what if I wanted to prove this using the exponents? I don't want to use this formula here. Then how do I prove this using some other property except using this? Because I assume this to be a property which I don't know. Then how do I use exponents by not using this exclusive formula of logarithms? So let's see just with a one statement out here in case of reconsidering this, where how do I get this statement? Now just I take this x into y as a power n plus m, through which I'm going to derive this part. I'm going to prove this using directly without using the formula log a power m is m log a. So in this case, when x into y is a power n plus m as taken from this statement, then I understand through the property that when x is a power n, then log x is n. Log x to the base a is n. Coming to the initial property, when x is a power n, this base will form the base for the log, and then xy comes here, and then n plus m. This is connecting the logarithms with the exponentials, the formula which we already taken in the previous case. So this is how I get the property here without using the formula. Connecting exponents directly with logarithms, I get this. Is how I understand the proof.